This question is from the 2015 higher level DCG paper and it's question B3. It's on perspective projection. Figure B3, just focus that. Figure B3 below shows the outline plan and elevation of a greenhouse based on the graphic on the right. Pictorial view of the structure is also shown down here at the bottom just for visualization purposes. Draw the given plan and make a perspective drawing of the structure given the following. So we don't need a front elevation here. Spectator point S is 4.5 meters from corner A, and they tell us at the bottom here it's at 45 degrees. The picture plane is touching the corner A. Horizon line is 3.25 meters above the ground line, and the door and window are in their closed positions. Use an auxiliary vanishing point where appropriate, so that'll be for the roof structure. It's not necessary to include hidden detail. Part B, the door is then hinged open as shown in the pictorial view until it is parallel with the picture plane. On the perspective drawing, show the door in this position. And part C, on your perspective drawing, show the roof window when it has been opened through an angle of 70 degrees. Okay, I'm going to start off with my plan view now in the top left hand corner of the page because the spectator goes down to the bottom right, and we're told its scale 1:50. So every measurement here needs to be divided by 50. So full width across is 4.5 meters. That's 4,500 millimeters divided by 50 is 90 millimeters. So I'm going to keep it as high up on the page here as I can, and as close to the left hand side as I can. So it is 90 millimeters. And the full distance down is 6 meters, which is 120. Okay, and the distance between them is 1.5. And the one at the top there is just halved, so that measurement there, that symbol just means it's the halfway point to find this line. Mine's about 45, so that'll be 22.5. Okay, that's my plan view finished down the top left. I'm told the spectator comes down from corner A at an angle of 45 degrees. And it comes down a distance of 4.5 meters from corner A, so that'll be 90 millimeters. Now, it's going to be quite tight for space here on the page, but we'll see how we get on. Okay, so same rules as usual. From S, we're going to get the cone of vision by joining the outer two corners of the object. And then once you have your cone of vision, you need to bisect the angle in between them to get your center line of sight. Describe an arc on both sides, and it's just off that line there. So that's my center line of sight now. Once you have your center line of sight, your picture plane has to be perpendicular to it, and it must run through the corner A. Going to extend it there a little bit further, and that's my picture plane. Now, next I can find my two vanishing points, so VP1 and VP2. To find them, you go from S parallel to the sides of the object. So in this case, it's vertical, and that gives me VP2. On this side, parallel to this side of the object, is horizontal, so that gives me VP1. Okay. Next up then, we need our ground line and horizon line. Now we keep the ground line as low as we can on the page. The horizon line will be 3.25 meters above the ground line, which works out at 65 millimeters. So I'm going to move my ground line down as far as I can here. So should work about there, I'd say. We'll call that GL. And then I'm going to measure up, what did it say? 3.25, so that's 65 millimeters for my horizon line. And make sure the two of them are parallel to the picture plane. Okay, and that's HL. Now, just move this up a bit so you can see it a bit better. Okay, next step then is to drop down my two vanishing points to my horizon line. Okay, so just make sure they're all lined up. Drop down VP1 to my horizon line, which will give me that point, and VP2. Now, that's the question fully set up. Now I can start drawing in the greenhouse here. So the easiest place to start is with the corner that touches the picture plane. So in this case, that's corner A. So I'm going to drop corner A the whole way down to my ground line. That gives me that point. I can join that point now back to VP1 and VP2 to get the footprint of the greenhouse. Once I've got those two lines, I know the two outer corners of the greenhouse hit there and there. So I can drop those straight down now as well and see where they cross those lines. That gives me that point and that point. And if I join those two now back to VP1 and VP2, I found the full footprint of the greenhouse. I'll just do these two lines in heavy. Okay, that's a good starting point. Next now, so I can mark up my true heights on the line that touches the picture plane. So that's this line here. The full height of the greenhouse, if you look over here at the side at that point A, is 2.25, which if we scale that down works out at 45 millimeters. So I can measure up 45 on that line, put a dot and join it back to VP1 and 2. Okay, so now I can draw in heavy. Those lines. Now, next part they ask for, they tell us to use an auxiliary vanishing point where appropriate. So we're going to need an auxiliary vanishing point now for the sloping part of the roof here. So if I'm standing at A, looking at the roof structure here, there's two different parts. It slopes up on this side and it slopes down on the other side. So I'm going to work from here, standing at S, it's sloping up. So I'm going to bring my auxiliary vanishing point above my VP1 line. Now, why do I pick the VP1 line and not the VP2 line? Because VP1 is parallel to the sloping edge of the roof. So you want, if you're standing on this line, you want to be fit to see the sloping part of the roof. This side you're just going to see a straight line. This side you'll see the slope. So we work on the line that's parallel with the sloping edge. So that's this one here. We're told the degrees in the question of the roof is 35 degrees. So from S here, I'm going to get my protractor, measure 35 degrees, and draw a line from S up through that point, and then from VP1 I'm going to go at 90 degrees to this line, which is vertical, and that gets me AVP1 there, auxiliary vanishing point 1. Then I'm going to use that measurement, so VP1 up to there, bring that down to my perspective view, mark it up from the line VP1, and that gets me AVP1 in the perspective view. Once I have that, then I can join this point up to AVP1, and then to get the very top peak of the roof, that would be it there. So I can bring that point back down to S, crosses the picture plane at that point, so I can drop that straight down to my perspective then. So that gets me one side of the sloping surface of the roof. I can just join the dots then to get the other side, and join it back to VP2 then to finish off the top of the roof. The end of the ridge at the top of the roof would finish here. So I can join that point back to S, crosses the picture plane at that point, and drop it straight down to my perspective. So I've used an AVP now to find the sloping part of the roof structure there, of the greenhouse. Last part then is to draw the lines on the side. So each one of these need to be brought down to S. Three. Drop them down then to the perspective view. The top ones would all join back. Now you can bring down the ones on the top ridge there as well, or you can just join them back to AVP1. Should give you the same answer. And then the door here on the sides. There's a door on the front. They tell us the measurements are 1.5, which is 30 millimeters in from the side. 30 and 60. I can bring down those 2 points then as well. And then I could see from the drawing here that the door goes up to the very top edge of the roof there, the sloping edge. So in this case, it goes the whole way up to the sloping edge here, which is basically on my horizon line. Okay, and that, the skylight as well, I'll just bring down those 2 points. So that point there is in the skylight. Join that back to S, that gives me that point. Drop it straight down, it's already brought down. That gives me that point there, and I can join that back to VP2. Okay, that's part A of the question finished. That's the full greenhouse now in the perspective view. Part B then, the door is hinged open as shown in the pictorial view until it is parallel with the picture plane. On your perspective drawing, show the door in this position. Okay, so we need to hinge it open so it's parallel with the picture plane. So I'm going to say it hinges from this side because it shows that in the pictorial view. If it hinged open like that, it will be that distance, and it has to be parallel with the picture plane. So set up my set squares there, and just draw my line parallel with the picture plane. So that'll be the door hinged open in the plan view. I can bring that down then. If it's parallel with the picture plane, it has to start from this point and it's going to go out along the side. So it must follow the picture plane, which is the ground line, and it must follow out that angle there. I know the end point goes to there, so I can bring that down to S. That gives me that point. And drop that straight down to the perspective view. So I know that that there now is the bottom edge of the door. The top of the door must be parallel with the picture plane as well. So the top of the door comes from here, happens to be on my horizon line. And drop it straight down. And that's my door hinged open in the perspective view when it's parallel with the picture plane. So that's part B of the question finished. Part C of the question then, on your perspective drawing, show the roof window when it has been opened through an angle of 70 degrees. Now an angle of 70 degrees, so the angle of the roof is 35 degrees. So in order for that to be open at 70 degrees, it's going to follow the same slope as the other side of the roof. Okay, so the easiest method for that, now I'm not going to have room here on, so the easiest method there would be to set your compass to the height of your AVP1. It's not going to change in this view because it hinges up, and then you're going to mark that straight down from VP1 in this view. Now the camera's not going to show it there, but if I just use that distance, that's my compass distance there, between AVP1 and VP1, and just move it down along the same line and mark down AVP1 below my vanishing point. And once I have that point below the vanishing point, I just bring my line up through it, like that, through both sides. Okay, and then to get the top point, when this hinge is open, so it's in that position, it's going to come out a little bit like that and back up to the original point. So just to show it in the camera there, it hinges there. As it opens, it's going to come up, out a little bit like that, and back in then to the original point, which would be there. So the top point is not actually going to change. So if I drop that down, that top point is there. So that will be the top point of the skylight then. Draw that in, going back down to the bottom, join the top point back to VP2, and the bottom point back down to there. Okay, and that will be your question fully complete, part C, with the skylight open. The door is in the open position there as well, and that's your question finished.